Okay, let's take a look at number 1 on page 296. Okay, I have a unit circle here that hopefully you have memorized. The different techniques you could have used hopefully from the notes, videos provided, and patterns that you see in the unit circle. Determine the non-permissible values of x in radians for each expression. So a equals cosine x over sine x. So for cosine x over sine x, the non-permissible value occurs when sine x is equal to 0. So sine x equals 0 at 0. For our ordered pairs here, remember it's always cosine theta, sine theta. So sine x is 0 at x equals 0, pi, 2 pi, etc. Okay, therefore, the general solution is x cannot equal pi n, where n is an element of integers. Okay, let's take a look at b. Sine x over tan x. Okay, so for sine x over tan x, the non-permissible values occur when tan x equals 0. Okay, so since tan x is sine x over cos x, the non-permissible values are when sine x equals 0 and when cos x equals 0. So cos x is equal to 0 at x equals pi over 2, 3 pi over 2, 5 pi over 2, and sine x equals 0 at 0, x equals 0, pi, 2 pi, and so on. So therefore, x cannot equal pi over 2 plus pi n, and x cannot equal pi n, where n is an element of integers. So these two sets of restrictions can be combined to be x cannot equal pi over 2n, where n is an element of integers. Okay, let's take a look at C. For cotangent x, 1 minus sine x, the non-permissible values occur for the denominator when 1 minus sine x is equal to 0. And for the numerator, this is in denominator, and in the numerator, when sine x equals 0, and that's in the numerator. So for the first restriction, sine x equals 1 at x equals pi over 2, 5 pi over 2, or in general, x cannot equal pi over 2 plus 2 pi n, where n is an element of integers. For the other restriction, x sine x equals 0 at x equals 0, pi, 2 pi, or in general, x cannot equal pi n, where n is an element of integers. D. For tan x over cos plus x, the non-permissible values occur for the denominator when cos x plus 1 equals 0, and that's in the denominator. And also for the numerator when cos x equals 0, and that's the numerator, because tan is sine over cos. So for the first restriction, cos x equals -1 at x equals pi, 3 pi. So in general, x cannot equal pi plus 2 pi n, where n is an element of integers. For the second restriction, cos x is equal to 0 at x equals pi over 2, 3 pi over 2, 5 pi over 2. So in general, x cannot equal pi over 2 plus pi n, where n is an element of integers.